how to integrate integral 0 to 2 pi tan of cos x times dx. Questions like these keep occurring in scholarships exams, competitive exams, and various other entrance exams. So I would be embarking on a quest to solve questions of this nature, so that the people who are watching this can benefit from this immensely. Having mentioned this, foremost what I wish to do is I would like to start off with that beautiful word, consider this integral, and then let me split this integral as 0 to pi tan of cos x times dx plus pi to 2 pi tan of cos x times dx. Now we need to know that tan x is an odd function and cos x is an even function. That makes a lot of difference. Now what I wish to do is I would like to take this as sum 2, and I will like to consider one part of this equation 2, which is pi to 2 pi tan of cos x times dx. Now I would like to make a substitution that let x be equal to some p positive pi. So dx is equal to dp, and this is going to be equal to, I'm going to set the limits within a few minutes. Before that, let me make the substitution. So this is going to be tan of cos of x is p plus pi and dx is dp. Now if we were to let x be equal to pi, then p will be equal to 0, and x be equal to 2 pi, then p will be equal to pi. So this is equal to, when it is pi it is 0, when it is 2 pi it is pi. Fine. Now what is cos of p plus pi? Now if you were to expand this, say cos of p plus pi, now what is this exactly? This is nothing but cos p cos pi negative sin p sin pi. Now this vanishes, but cos pi is negative 1, so this is going to be cos p of negative 1, which is nothing but negative cos p. This is what we are getting. This is for your understanding, right? If you know what is cos of p plus pi, you can directly substitute it. You don't have to work out these things, and this is just some basic information. So this is going to be equal to 0 to pi tan of negative cos p times dp. Now I mentioned in the beginning tan is odd. So what is the meaning of tan being odd? It means tan of negative theta is equal to negative tan theta. So this is the meaning. Tan of negative theta is equal to negative tan theta. So this is equal to negative integral 0 to pi tan of cos p times dp. Now p is the variable under question. Now if I were to change p to x back, there wouldn't be any change here. So let me show you that. Now let p be equal to x. So dp is equal to dx. The limits, when p is equal to 0, x is equal to 0. When p is equal to pi, x will be equal to pi. So this is nothing but negative integral 0 to pi tan of cos x times dx. Right. Now I can go back. Now what did I do? I considered this part of the integral, and I have got this to be the answer. Negative integral 0 to pi. We started with pi to 2 pi and we have ended up with 0 to pi. So let me go back to 2 and substitute whatever I've got here over here. That's exactly what I'm going to do. So I hope that is in the frame. So let me write that down. Therefore 2 can be rewritten as, this is equal to integral 0 to pi tan of cos x times dx positive. This is actually negative, so let me place the negative sign like that. negative integral 0 to pi tan of cos x times dx. This is equal to integral 0 to pi tan of cos x times dx negative integral 0 to pi tan of cos x times dx. Positive integral 0 to pi tan of cos x dx, negative 0 to pi tan of cos x dx can be cancelled and giving you the value 0. Now this is the answer that we are getting. Now this answer can easily be visualized right from the question, right? Because the limits are actually from 0 to pi and then pi to 2 pi, right? So it's coming back to the original point where it exactly started, and we got an odd and we got an even, and outrightly we can say the outcome is going to be equal to 0. But the problem is, in most of the questions they wouldn't exactly accept you straightforwardly giving them the answer 0. They want the steps, they want how exactly the algorithm can be designed, and the best way to do is to give them the steps. So that is why I have taken this measure to give every step that went into this solution part. Thank you everybody, enjoy your day.